Hello and welcome to our fifth lesson in our fourth unit, Graphing Quadratics, in our grade 10 academic math class. So today we're going to learn a procedure called completing the square. And completing the square takes us from the standard form version of a quadratic, which you see listed right here. So this is standard form, y equals ax squared plus bx plus c. We learned about this in the last lesson where our a value tells us our direction of opening and our plot pattern, and our c value tells us the y-intercept. And we're going to learn how to go from standard form to vertex form. So here's vertex form over here. That's y equals a x minus h all squared plus k. Because what we want to do in moving from standard form to vertex form is we want to get the vertex. In the last lesson where we learned what standard form was, we learned that it shows us the a and the c value. And in the last lesson we gave you the axis of symmetry, so you had half of the components that make up our vertex. Sometimes you're not going to be given that, but as we know, having the vertex is the key to graphing a quadratic. So sometimes you need to get from standard form to vertex form. The procedure for that is called completing the square. So this can be a fairly complicated procedure if you don't understand it. So what I'd recommend is, here is our worked example. What I think is a good idea is to pause the lesson, copy this down so that you have it and you're ready just to sort of listen and follow along to my explanation as I'm going through it. So hit pause now, copy it out, and then come on back. I'll be waiting. Okay, you're back and you've got it copied out. So what we're going to do with our worked example, y equals 2x squared plus 12x minus 3, to start this procedure of completing the square, we're going to common factor out the a value from ax squared and the bx terms only. Now the reason that we're doing that, so let's just see what that is. So our a value here is 2, which I've common factored out. And when I common factor 2 out of 2x squared plus 12x, I'm left with x squared plus 6x. Now, the reason that we do this is at the heart of completing the square is this idea of building a perfect square trinomial. So what is a perfect square trinomial? Well, at this point I'll tell you that it starts with a perfect square, and x squared is a perfect square. It's 1x squared. Both the 1 and the x squared are perfect squares, which means that they have two identical factors that multiply together to give you that product. We had to common factor out the 2 from the first two terms so that we were starting our perfect square trinomial with a perfect square. So that's our thinking. The negative 3 on the end, as you can see, that just kind of gets walked down from the first step to the second step here. So that's our first step, common factor out the a value from the x squared and the x terms. Okay, let's read instruction number 2. Instruction number 2 says create a perfect square by finding b over 2 squared. So let's talk about what that means. In building a perfect square trinomial, what we're trying to do, I'm just going to change up my colors here a little bit. What we're trying to do is create something that when you factor it, so we're trying to create a quadratic, a trinomial quadratic, that when you factor it results in two identical binomials. So for example, something like 2x or x squared plus 2x plus 1. If you were to factor this, you would end up with x plus 1 and x plus 1. So those two binomials are identical, and if you were to write that in an even more factored form, you'd end up with x plus 1 all squared, x plus 1 all squared. What's nice about that is we've got something that looks an awful lot like the heart of our vertex form, which is right up here. This x minus h all squared, if we create a perfect square trinomial, we will be able to have that in our final answer. So that's the why of what we're doing. The how of what we're doing is taking half of our b value and then squaring it. So the rationale is that that's how you build a third term. Like let's say you didn't know what this value here was going to be. You're like, what is this value here going to be so that I can create this perfect square trinomial? Well, the idea is that you take half of this, which is going to be 1, and then you're going to square it, and that's going to give us 1. So that tells you what value you can put here so that you can go on to then factor it and have a perfect square trinomial factored down to an identical binomial squared. So let's look at that in the context of our example. So what we've done here is you've got 2 bracket x squared plus 6x, and now this part here is what we're adding. We are finding what value we can have there to make this a perfect square trinomial. So that's what's happening there. That value will be half of 3, or half of 6, which is 3, and then we square it, which will be 9. And you can see that that's showing up, whoops, I should get my highlighter, that's it showing up right here, the plus 9. But the thing is, we can't just willy-nilly go about adding 9 to an equation. Normally, because an equation is something that's equal on both sides, if we were to say add 9 to the right side of our equation, normally we would then add 9 to the left side of our equation. However, we don't want to do that in this case because we want the y value all on its own on the left so that we can continue building this equation in this way, so that we can get something that we can factor at the end. Another way to ensure that this equation stays equal is to, once you've added 9, you go on to subsequently subtract 9. Now that seems counterintuitive, but remember, we're doing it for 2 different reasons. The first one, so this guy here, we are adding it to create the perfect square trinomial that we're going to factor. We subtract it in order to keep the equation balanced. That's why it's there. So hopefully that makes sense. And then you've got -3 on the outside again. So once you actually evaluate what 6 over 2 all squared is, that comes out to be 9, which you can see. There it is. Now, the last thing that we want to do before we get to the factoring and simplifying stage is have only the 3 terms that we want to factor left inside the brackets. Now, that's a little bit of a problem at this point because we've had to put this subtract 9 in here in order to keep this equal. So how do we go about getting it out of the brackets? Well, we introduced it to the brackets as a way of balancing the equation, and inside those brackets it had already had 2 factored out of it. As you can see right here, the 2's hanging out front. So how do we get the 2 out of the brackets? Or sorry, how do we use the 2 to get the -9 out of the brackets? We are going to essentially multiply it by 2. So you have -9 multiplied by 2. Essentially now it has been freed of the brackets, and that's going to give us -18. So you can see that -18 reflected, so there's -18, and you can see it now reflected down here. So what's left for us? Now that we've gotten the 18 out, the -9 out of the brackets by multiplying it by 2, now we're in a position where we are going to just factor this trinomial, which comes out, as I said, to x plus 3. I'll put that intermediate step in there. That would give us x plus 3 and x plus 3. And we can rewrite that as x plus 3 in a bracket, all squared. And then we simplify -18 and -3, and that gives us -21. So that's the procedure for completing the square. Again, going from something that didn't tell us a whole lot to x squared plus 12x minus 3. So we have the y-intercept is -3, the direction of opening is up, we can figure out the plot pattern. Now that we've changed it to this form, we actually have more information we can use when we're graphing. So if we were going to do that, what is the vertex here? The vertex, of course, is the h and k value. So that looks like a looks like a positive 3, but is actually a -3. So our vertex is -3, -21. So we take the k value as it appears. The next question is, what is the axis of symmetry? Well, the axis of symmetry is x equals h. So for us in this question, that would be x equals -3. That's the x component of our vertex. Do we have a maximum or a minimum? Well, our parabola here, if we were going to sketch it, our parabola would be opening up. So our parabola is going to have a minimum value. And last but not least, and this is a bit of a new one, what is the optimal value? So the optimal value, this refers to, and I'll just make a little note of it down here, this refers to the y component of the vertex. So the y component of the vertex for us is going to be -21. In this case, that's going to be a minimum value. That's going to be the lowest value that our parabola hits along the way. And that's completing the square. Now we're approaching the 10-minute mark, so I'm going to stop the video here. maybe watch it again. If I'm being totally honest, this is one of the more complicated procedures that we do in the grade 10 academic math class. It's not necessarily hard math to do, but we just have to remember which steps to take, and hopefully the understanding of why you're doing them will make that a little bit easier. Then we'll go on. We've got some examples, 1, 2, 3, 4, 5 examples to tackle here, sort of increasing his difficulty as we go along. So, let's finish up this video and let's come back and we'll work through these examples. We'll see you soon in part 2.